keeps going and keeps going. It's just mesmerizing to watch this thing and see the scale here. And it gives you a little taste of what God's mind is like, to be able to think infinitely. We can only process just a little bit of information at a time, but God's mind is truly infinite. So one of the interesting areas to explore, and what I want to do now is just kind of spend some time exploring this shape that exists in the mind of God and has existed in the mind of God from creation, that was only discovered in the 1980s. And we can zoom in, for example, on this cusp between the main cardioid and the disc. And we find they call it the Valley of the Seahorses, because you see over on the right side, it looks like seahorses. They're upside down, because the way I've zoomed in on them here. Now, the colors are arbitrary. I can make them whatever I want, and we'll change them every now and then just to keep things interesting. But just keep in mind, black always represents numbers that do belong to the Mandelbrot set, and then colors represent those that do not belong to the Mandelbrot set. And bright colors are very close to being on the Mandelbrot set, but not quite a part of it. So let's zoom in on one of these seahorse structures over here. You see it looks like an upside-down seahorse. Isn't that fascinating? And quite beautiful. And I need to explain a little bit about what this means, because if the points are very bright, that means it's very close to the Mandelbrot set. And you might look and say, but yeah, that bright hub doesn't look like it's anywhere close to it. It is. It's just, you need to realize that there is a very thin black thread that's wiggling around and making that shape, you see. It's just so thin, it's thinner than the pixels that the computer can plot. So everywhere you see structure like that, there is a very thin black thread that's winding around and creating that wonderful shape. Well, let's zoom in and find out what this seahorse is made of. It's the central hub there looks kind of like a spider web type structure, right? You got the spokes and the rims around there. And I found from experience, you can zoom in on the center of that till your heart's content, and it doesn't really change very much. It goes on infinitely. So again, the infiniteness of the mind of God. And so I thought, well, okay, let's go off to the side and figure out what the strands of the spider web are made of. So let's go off to the side here, and we find that the strands are made of more spider webs, which is kind of interesting. And we zoom in a little bit more, and you find that there's sort of two hubs there. You see the bright yellow hubs. And then in the middle, it goes from 2 to 4. And as we zoom in, it'll go from 4 to 8 to 16, 32, 64. It doubles each time. And as we zoom in on that central hub, we find, oh, isn't that interesting? You see it going from 4 to 8 to 16 and so on, and in the middle, of course, you have another baby Mandelbrot set. Quite fascinating, really. And again, there's an infinite number of these babies built into the overall shape, which I think is amazing. And again, look at how small this is compared to the overall shape as we zoom back out. It's just a tiny little infinitesimal, and we could have zoomed in on any one of those strands. I just picked one at random, and there it is. So pretty remarkable. Let's go back to that valley. Now, the Valley of Seahorses is on the right. On the left, we find the Valley of the Double Spirals. And I'll zoom in on one of those now. This is my favorite part of the Mandelbrot set. I think they're very beautiful. They remind me of spiral galaxies, actually, which is an astronomer I really appreciate. God apparently likes spirals because he's built a lot of them into nature, and he's built them into math, which is remarkable. Who would have guessed that there would be a spiral, a beautiful spiral, built into that little formula, z squared plus c, or rather built into numbers when we run them through that formula. Pretty amazing. It's a double spiral because there's actually two strands that wrap around each other. If you trace one strand, you'll find that there's a strand in between. And so it is a double spiral, as are spiral galaxies, by the way. And let's zoom in on that a little bit. And again, I've found you can zoom in on the center forever, so we'll zoom in on the side, and you find the spiderweb type structures, you find more double spirals, and you find a new structure. I call them bow ties. They're kind of in the middle. You see it looks like kind of like a little bow tie, right? And it's got two double spirals that intersect in the middle. Quite beautiful. Again, what you're seeing here, the Mandelbrot set, it's just incredibly wiggly. It's so wiggly. It's making these wonderful shapes. And that's what the points that are very bright are very close to that thin black thread that's wiggling around and making all these wonderful shapes. So we'll zoom in on one of these bow ties. And we find that again, you have the two double spirals. We zoomed in on a double spiral, and we found that it's made up of multiple double spirals. And they go from 2 to 4 to 8 to 16 as we zoom in on the center there. And in the middle, you find another mini Mandelbrot set. You're not surprised this time, but there it is. And quite beautiful. Who would have imagined that such beauty would be built into numbers? Well, in the Christian worldview, that makes sense. We serve a God who is beautiful, who makes beautiful things. And when we examine the way God thinks about numbers, which is what mathematics really is, we find it's immensely beautiful. All that, just a map of what numbers belong to that little formula when you run them through that algorithm. Isn't that fascinating? And this, of course, was astonishing to mathematicians when this was discovered back in the 80s. So then it occurred to me, well, is there something special about that formula? I mean, did we just happen to stumble upon to an amazing formula? What happens if we change it? So I thought, okay, let's take, what happens if we go z cubed plus c? Well, I ran the computer code through that, and it turns out you get a different shape. Interesting. And very similar in some respects, but different in others. The shape here, the main shape, is called a nephroid. A nephroid is what happens when you take a circle half the size of another and you roll it around, then you get that shape. And you can see it's a perfect nephroid. Really amazing. And then instead of circles growing off of it, you have cardioids growing off of it. Notice everything's gone up by one. The Mandelbrot set had a cardioid which has one valley. This one has a nephroid which has two. And the circles growing on it, which have no valleys, now are cardioids which have one valley. Everything's gone up by one. That kind of makes sense. We went from z squared to z cubed. I guess that makes sense. Okay, what happens when we go z to the fourth? Well, that's what you get. Okay, what happens if you go z to the fifth? Interesting. You notice the number of lobes is one less than the number. So z to the fifth, you get 4 lobes. Z to the sixth, you get 5 lobes. It occurred to me if I went z to the seventh, I could get snowflakes. And you sure do. And if you zoom in on it, do you get snowflakes? Absolutely. You zoom in on it, you get snowflakes everywhere. Isn't that wonderful? Did you know that such beauty was built into numbers? Okay, so what does all this mean? We got these wonderful shapes, and it's very pretty, Dr. Lau, but who cares? Well, I want to ask, what causes the beauty in fractals?
So I think that's a great question. You can look online and find the Mandelbrot slit. There's a lot of generators out there. If you want to see the whole video, it's an hour long. Look up Answers with Genesis Mandelbrot set, and it'll take you to Dr. Lyle's video. There's several of them out there. Like I said, there's a lot more to it. I just had to truncate it. But he asked a good question. What causes the beauty in numbers? I mean, we're just graphing numbers, but it's beautiful. I mean, everyone can see the beauty, and it's not just colors. If you go on with his talk, he changes the colors to just black and white. It's still beautiful. It's not the colors. The colors are his artistic flair. I like what he did. Why? Well, Christian worldview, it's quite easy. Like he said, we serve a beautiful God, and he created beauty for us to enjoy. Atheist worldview is going to say, pattern does not imply person. There's all kinds of patterns in nature. There's crystalline forms that don't generate beauty, although I find them beautiful. I love crystals. But that's going to be their argument. They're going to say, fractals, crystal growth, branching trees, turbulence, all these different things. There's rich information, but they're generated by impersonal rules, like a mathematical formula. So why do you Christians think it implies God?
Somebody had to think that.
Somebody had to think about it. And why does it generate? This was not predicted to generate such beauty.
Not until 1980.
Not until 1980. We had to have a computer to run it. You can manually plot the Mandelbrot set. He talks about this in his video, but it would take, you need hundreds of thousands of iterations just to get the original shape, and then all those little detailed ones. Yeah, so as we get better computers, actually my friend Walter plotted this for me, so I have a little engine that I can play with. Like I said, you can find them online. I mean, it's not sophisticated math, believe it or not. It's just it takes a pretty significant computer to plot it.
Is it God because it's absolutely perfect?
Well, I think it's a good indication. I think the reoccurring fact and the infinite fact, or the fact that it does math is a remarkable trait. But the question I asked, and is it just the Mandelbrot set? You know, is this the only one? He showed you variations of it, but it was still basically the same formula. So I'm going to show you about 2 more minutes of his video. He's going to talk about fractals.
From above, and they kind of branch, and they branch into branches, and so on. Clouds tend to be fractal. They don't repeat exactly, but am I looking at the entire sky, or am I looking at one very small section of the cloud? It's hard to tell, because the same kinds of patterns repeat. The way lightning branches is fractal, because you have a main bolt that branches into smaller bolts, which branch into smaller ones, and so on. And so lightning, very beautiful, and because it has that fractal quality to it. And it's really neat, too, when you watch it in super slow motion. You can see how it branches out into all these different branches. That's a fractal, till the leader connects, and then most of the current goes down the leader. Quite fascinating. So here's my question, then. Why do fractals occur both in math, which exists in the mind, it's conceptual, and in the physical world, which is made up of atoms and does not exist in your mind? Right? I mean, you have this shape, that's a multibrot, that exists only in the conceptual world of mathematics. We can plot it, but you could never touch that thing because it's not physical, it's not made up of atoms. But that one is, and they look remarkably similar. This particular shape here is part of the Mandelbrot set, looks like a bolt of lightning, but it's not made of atoms. This one is. How is it that conceptual things that exist only in the mind also occur in the physical universe? This particular shape, that might look like a plant. That's actually a mathematical graph called a Barnsley fern. And a Barnsley fern is such that each leaflet is the entire shape. Let me show you. Isn't that interesting? Let's do it again just because it's cool. See, the entire shape, each leaflet is the entire shape. Fascinating. You can't touch that, though. It doesn't exist in the physical world, but that does. It's very similar. This stuff right here, that's a mathematical graph. That doesn't exist in the physical world, but that grows on your windows. This particular mathematical shape, cones on cones, it does not exist in the physical world, whereas this, unfortunately, does. This particular shape, that's part of the Mandelbrot set. It's a double spiral. You can't see that in a telescope because it's not made of atoms. It doesn't exist physically in the universe, but that one you can see it in a small telescope. The Whirlpool Galaxy, not too far off from the Big Dipper. So how is it that math, which is conceptual, you find these shapes, and then in nature, which is physical, you find the same kinds of shapes?
So it's a great question. In case you didn't get the joke, this is a kind of broccoli. You know, so it's like, unfortunately it exists. Most people don't like broccoli. Pine cones are the same. But as you look through this, I mean, which is real and which is conceptual? And which is not beautiful? I mean, both the conceptual and the physical are beautiful. Why are both the mathematical conceptual world and the physical world the same? Well, as a Christian, we believe it's because there's a creator. But I want to take it a step further. I may run a little late, but I think this is cool. I'm going to just talk about 2 other mathematical formulas. Helix and vortex. These are common if you do trigonometry. It's not complicated math. It just looks complicated. And there's lots of different forms of it. When you graph them, they kind of look like this. And even though they're colored, if I didn't color them, they're actually still kind of cool. They're pretty. It's very interesting. Now I'm going to show you versions of these, both mathematically, conceptually, and then in the physical world. This is what they call a torus or a vortex ring. This is Mount Etna in Italy generating vortex rings, smoke rings. Those are smoke rings coming off of Mount Etna last year. I got this from Wall Street Journal. It's the tag's there. So you see, the physical world generating things amazingly beautiful that are also seen in the conceptual world of mathematics. So I thought that was cool. Now this one, we might have some familiarity with. This particular storm I have a lot of familiarity with. This was Pepito, or Magny. At the time you see that eye wall, it was probably the strongest typhoon on record. And my family and I are right here of November 2 years ago. It was a lot of fun. It died down as it came on. I think it's the top 10 now as far as landfall. But again, look at the physical world and the conceptual.
And they always turn the same way.
Depends on which side of the equator you're on.
Right.
They turn the opposite way on the opposite side. Now well, what about this one? I mean, obviously, he talked about whirlpool